Welcome to Ask an Expert, where our technical product expert answers questions from our customers. Hello, this is John Appleson, Marketing Manager with Pepperl+Fuchs. So welcome, Tracy, and thanks for being here.
Hi, John. Thanks for asking me.
The first question asks about the temperature rating of the NJ6-F-N. The customer would like to know if this inductive sensor will operate at minus 40 degrees Celsius. Tracy, is this the correct sensor to use for his application?
Temperature ranges for storage and operation of our products can be found on the sensor data sheets, and these can usually be downloaded from our website. In the case of this sensor, the listed range is minus 25 to 100 degrees C. Sensor temperature specs are determined based on the tolerances of the components that make them up, but because we don't know which component will go out of tolerance or even fail if the sensor is operated outside the stated range, there's no way to predict how or when its response will deviate from its other specifications. For this customer's low temp application, we do offer sensors with operating temperature ranges down to minus 40 C, but they have different housings from the flat F-style housing he's currently using. An example with similar range and function is cylindrical model NJ5-18GK-SN.
This customer needs to sense a 1.6 by 2 inch piece of reflective tape and is using the Series 28 retroreflective sensor. The target is on a cart moving laterally from side to side and is about 3 feet from the sensor. How far can the cart move from side to side before the tape can no longer be seen by the photoelectric sensor?
To answer this customer's question, two factors come into play: the sensor's light spot size at the distance the target reflector is located, and the size of the reflector. As long as enough of the light spot hits the reflector and returns to the sensor, its output will be activated. Once the reflector on the cart moves far enough in one direction or the other, not enough light will be returned and the output will deactivate. Light spot size can be typically found on the sensor's datasheet, and in the case of this sensor, there's even a response curve graph that can be helpful. The graph shows 5 curves, each of which corresponds to a different target reflector. The reflector listed that's closest to the customers is a larger 4-inch square piece of reflective tape. So if we look at the 3-foot distance for that curve, we can estimate that the offset distance to either side will be somewhat less with the smaller 1.6-inch by 2-inch reflector than is shown for the 4-inch square one. Ultimately, of course, the customer's question is best answered with testing.
Tracy, this next customer would like to detect the horizontal position of a hoist that operates in 2 planes, horizontal travel and vertical lift. The overall horizontal travel distance is 150 feet. He'd like to use Ethernet IP interface to his Control Logix safety PLC. What would you recommend?
We have several options for position measurement that might be used for this customer's application. And in each case, either horizontal or vertical movement can be determined. One option is our VDM 100 series of laser distance measurement sensors. These are retroreflective, which means they require a reflector, and are available with an Ethernet IP interface built in. The sensor is mounted at one end of the travel path and the reflector at the other end, and as the two move toward and away from one another, the distance between them is measured using laser time of flight. Another option is our WCS system. This product uses an absolute value coded rail that's installed along the travel path, and a read head that travels over the rail and reads the absolute position. The reader has serial output, but we offer a separate Ethernet IP interface for it. The third option, our PCV system, is similar in function to WCS, but the reader is camera-based, and the absolute position is read from an adhesive strip of data matrix codes. There's a PCV read head whose output matches that of the WCS read head, so that the same Ethernet IP interface can be used with it.
In this next application, the customer would like to sense plastic and metal cans through a plastic tray that is approximately 1/2 inch thick. Tracy, what are our options here?
The customer can use an inductive sensor to detect metal through plastic. Which model to select depends on the size and material of the metal to be detected, and the distance that he wants to mount the sensor away from the target. The plastic tray will take up space, but it won't affect the sensor's ability to detect the metal on the other side. So for detecting metal through a 1/2 inch thickness of plastic, the sensor will need to have more than a 1/2 inch range. For the detection of plastic through plastic, things get trickier. If the two materials have different dielectric properties, it might be possible to use a capacitive sensor for this, but only if the target's dielectric constant was significantly higher than the tray's. Looking at things differently, if the plastic tray is clear and the target can is not, a photoelectric sensor might be used for detection. In this case, the can material, whether metal or plastic, doesn't matter, as long as it reflects light.
Well, that concludes this segment of Ask an Expert. I want to thank Tracy for joining me today and thank our audience as well. For additional information, here are 5 easy ways to connect with us.